All right, Worthington High School juniors, our next lesson here, our next video for the MCA is going to be on working with polynomials in expressions. Should be pretty basic stuff, but there's a lot of different ways you can use polynomials and work with them. So I'm going to kind of cover those scenarios. So first off the bat, the prefix poly means many, okay? But there's different types of names of polynomials based on how many terms they have. And in fact, if you hear the word monomial, that simply means one term. Now, it could be a number, it could be a letter, it could be a number times a letter, but one term. Okay, now maybe you'll understand more what that means when a binomial is going to have two terms. So if I would go x positive 7, two separate terms combined, that would be a binomial. Okay, or x squared plus 7x, that's a binomial. Trinomial's got 3. You guys all know this, so we don't need to belabor that, but those names are used all the time. So we want to go add, subtract, multiply, divide these things as needed. Okay? So I just put some problems together. You might have one problem where they ask you to simplify with a polynomial on the state test on the grad portion of it. So here I've got two trinomials. They use parentheses around these things because it's a grouping of terms. These 3 and these 3. If you're going to add stuff, remember you got to have a like stuff. You certainly don't need the parentheses if you're combining. You can just get rid of them. It's like 2 trays of food down at the lunch line, and one kid says, I've got a funny chicken patty, and the other kid says, I got a funny chicken patty, and oh, we got 2 funny chicken patties. Okay, are we going to eat them or not? Alright, well, here I got 2x squared, there's one more x squared. The thing you got to remember, when you're adding or subtracting, things don't change. You just get more or less of them. Okay, so if I had 2 pretzels and you had 3 pretzels, they don't turn into Reese's peanut butter cups. They're 5 pretzels. So 2x squared and 1x squared is 3x squared. Negative 3x, positive 5x. Notice how I underline what I'm combining. I think that's a very important thing to do. 8, negative 10, negative 2. You box it up. Okay? Pretty simple. Here I got a negative in front. Negative means subtract. The way I like to teach that is simply take the opposite. A negative in front of parentheses means opposite of. And you got to make sure to opposite every one of these. Okay? So 4x cubed, 2x squared, negative 7. Opposite x squared, negative x squared. Opposite negative 3x, positive 3x. Opposite negative 10, positive 10. And then you can go ahead and you can combine the like stuff. 4x cubed has got the most power, that's up front. Got 2x squared, take away 1. I've got 3x, and then the numbers combine to make positive 3. When you're finished, you want your powers to go down, just like a staircase. 3, 2, 1, none. Always have constants on the end of these polynomials. Okay? Here's another example, but I've got multiplication of each binomial first before I combine. So I'd have 6x squared, negative 8x. Please circle that negative with that 3. So it's going to be positive 6x squared, negative 24x, and then we're going to be combining again. Looks like 6 and 6 is 12 of them x squared, negative 8x, negative 24x, negative 32x. Boom. There we go. Okay? Now, when you have multiplication, you have to look at the powers, and you got to understand something. When you multiply, you add the powers. That's why I put maps. I don't know if you caught that. Before I put saps, when you subtract or add, the powers stay the same. That's important. You're not changing what you have more or less of it. Here, you're changing what you've got. When you multiply, the factors add up. So, we're multiplying. 2 times negative 3 is negative 6. Here's 3 x factors. Here's another one. You add those powers. So negative 6x to the 4th, y to the 3rd. Okay? So you got to be able to add the powers when you're multiplying variables like this. Here I've got a monomial times 4 terms, it looks like. Got to remember to add the powers. So 3 times 2 is 6. X to the 2nd times x to the 3rd, add the powers. X to the 5th, negative 12. X squared times x squared is x to the 4th. 3x squared times 3x would be 9x cubed. Negative 15x squared. And you won't see a lot of these on the MCA because there's not a word problem attached to it. So, but if you have it, you have it. You probably should count your blessings. Here would be a binomial times a binomial. We reviewed this before. When you got two things times two things, it's 4 multiplications. You bring the first thing through using the distributive property. So that's 12m. Please remember that's squared. M times m is m squared. 4m times 2 is 8m. Bring the negative 3 through there. Negative 9m. Negative 6. Combine all like stuff for the guts. My binomial times my binomial gives me a trinomial. Here I've got a binomial times a trinomial. I can do the whole problem here, but you're going to bring the 2x through. So 6x cubed, negative 6x squared, positive 16x. Got to bring the 4 through. Make sure to line up whatever it is you have with what it's going to combine with. Maybe I am doing the whole problem. Okay, 6x cubed, positive 6x squared, positive 4x, positive 32. And there you go. Okay, here I'm squaring a binomial. The easiest way to remember this is just write it down. M plus 6 times m plus 6. When you do that, you will get m squared plus 12m plus 36. Okay? In reality, you can square the first piece and you can square the last piece, but you got to remember to multiply this and double it to get the middle. Okay? So, the safe route, if you're asked to square a binomial, is to write it down and go ahead and do the multiplications. So 16t squared negative 20t, another negative 20t, positive 25, 16t squared negative 40t, positive 25. I'm multiplying polynomials here. Okay? So, lots of examples. Okay? When I talk about division from a polynomial, you kids, you can reduce things in algebra just like you reduced fractions back in 5th grade. A fraction would have a numerator and a denominator, and we look to divide a common factor away. Now, I got 12/18ths, I could divide a 2, I could divide a 3, but if you want to do the most damage, you divide the big dog out of the house. Divide by the greatest common factor. So in algebra, taking the greatest common factor from a polynomial is the first step in what's called factoring it. Okay? So I look at a binomial here and I look at it and say what's common. Numerically 3 goes into 3 and 12. They also each have an x factor. So I could divide 3x from that binomial. And then I'd have x minus 4. Okay? So essentially you're undoing the distributive property. Rather than multiplying a factor through what we just did, you're dividing a factor from. Okay? Here I've got a trinomial. Is there anything common? 4, 10, and 20? Well, 2 goes into all of them, and they all have at least one x factor. So 2x would be the greatest common factor. You write that down with parentheses. 2x squared, positive 5x, negative 10, I believe. And there you have it. Okay, last little guy. Looks like a 2 is common, and they both have p's. This one has 4, this one has 2. I can take out 2 of those p's. And that'll give me p squared. Now here's what's interesting. When you divide the whole thing from the term, you have to remember that it's still going to be multiplied by 1 to get that back. Okay? So, taking a GCF out. And lo and behold, I guess that's it. That surprises me. Add, subtract, multiply, dividing a GCF from a polynomial. These are all basic things. May or may not have it on the state test. Should be able to handle these items. All right, we'll catch you guys in the next one, and take care.